So in these next two examples, we're working with sine and cosine, which is nice because, as we saw in the previous example, tangent can be kind of a slog with all the simplifying that has to happen. Sine and cosine definitely work out to be easier. But the difference now is we're given an angle that's in radians rather than an angle that's in degrees. So we could try to work with the angle in radians and figure out what do I have to add or subtract in order to make pi over 12. But what is probably the easiest thing to do is to just take that pi over 12 and convert it into degrees and then figure out how we can combine two unit circle angles to make that degree measure. So we use our conversion factor of 180 over pi. So we can see that the pi's cancel out. And so we're really left with 180 divided by 12, which equals 15. So what we really are working with here is the sine of 15 degrees. And so now trying to make that out of a couple of unit circle angles is probably a little bit easier. So probably the easiest way to do that is to say sine of 45 minus 30. Now we could have used sine of 60 minus 45. We could use sine of 135 minus 120. Any of those will work and they'll lead us to the same correct answer. I just chose to use angles that are in the first quadrant just because they'll be a little bit easier to work with. So I mean sine, or 45 will be our alpha, 30 will be our beta, and so then we just have to plug into the correct formula that we have up above. So we've got sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. Just choosing from the correct formula up above in our notes. And so now I'm using my unit circle to find all of these ratios. So sine of 45 is root 2 over 2 times cosine of 30 is root 3 over 2 minus cosine of 45 is root 2 over 2 times the sine of 30, which is 1/2. So as I mentioned in the previous video, root 2 times root 3 gives us root 6 over 4 minus root 2 over 4. So we're seeing those same numbers appear. We've got root 6 minus root 2 in the top, all over 4 in the bottom. This one actually ends up being the exact same answer as our first example. And the reason is when you have the sine of a 15 degree and the cosine of a 75 degree angle, those are going to be the same ratios. We've just flipped which angle within the same triangle we're working with. For the last one of the set, so we've got negative 13 pi over 12. So we're going to convert that into into degrees by using our same conversion factor, 180 over pi. So if we cancel out the pi's, we do our simplifying, we're going to end up with negative 195 degrees. So this might require a little bit more creativity, a little bit more thought for us of how we can use our unit circle angles to make negative 195 degrees. Again, just like with that 15 degrees, there are lots of options that we can use. So in this case, one such option would be 30 minus 225. And so if I go with that, I can see that that equals negative 195. And so now I just need to make sure that I use the correct formula from up above. So that's going to be cosine 30, cosine 225, plus sine of 30, sine of 225. So from my unit circle now, I've got all these ratios that I can find. Cosine of 30 is root 3 over 2. Cosine of 225, so we're in the third quadrant, so that's going to be negative root 2 over 2 plus sine of 30 is 1/2 times the sine of 225 is negative root 2 over 2. So we're getting negative root 6 over 4 from the first part of our expression. We're getting negative root 2 over 4 from the second part of our expression, or if we combine them into one expression, negative root 6, whoops, let's try that again, negative root 6 minus root 2 all over 4. So once more, we see that root 6 and root 2 in the numerator. We've got the 4 in the denominator. And for all of our sine and cosine answers, we're going to get some sort of answer that looks like this. So sometimes we're given these expanded expressions, as we can see here, and we're asked to work backwards, essentially. So we've got this sine of 1.1 radians times the cosine of 4.6 minus the cosine of 1.1 radians times the sine of 4.6. And so hopefully we can recognize this if we think of these as our alpha and betas. So we have sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. And so hopefully we can recognize that as being a expanded version of sine of alpha minus beta. And so then that means I can collapse this expression into sine of 1.1 minus 4.6. So I'm just working backwards. I have the expanded expression, and so instead of having to push buttons for sine of 1.1 and the cosine of 4.6, multiplying those results, and then subtracting the product of cosine of 1.1 times the sine of 4.6, I can instead collapse this into sine of 1.1 minus 4.6. I can do the subtraction inside the parentheses. Sine of negative 3.5 is all I have to do. Now I just have to make sure that my calculator is in radian mode, and so if we do that, if we push buttons on our calculator, the sine of negative 3.5 radians is going to be 0.351. For the next example, so we can see that that is an expanded version of one of the tangent identities. Again, if we think of pi over 16 as our alpha and the 3 pi over 16 is our beta, right? Now, if we see this as instead being the tangent of alpha plus beta, again, just matching up the expression with the formulas that we have at the top of our notes. So we can rewrite this as the tangent of pi over 16 plus 3 pi over 16. Well, now, again, instead of having this more complicated expression where I'm going to have to enter a whole bunch of things to get to the correct answer, I can add these two together. So pi over 16 plus 3 pi over 16 makes 4 pi over 16. Well, 4 pi over 16 reduces to pi over 4. Well, the tangent of pi over 4 is about as easy as tangent gets. Our answer is 1.